This video presents how to convert sentences to first order logic or predicate logic. First order logic or predicate logic is a logical representation of any real world sentences. Unlike propositional logic, in predicate logic we could able to represent any type of sentences with quantifications. Here we have two types of sentences. One is atomic sentence, another one is complex sentence. Atomic sentence is a simple sentence which cannot be further divided into subparts, whereas complex sentences which can be divided into some atomic sentences and which are connected by logical connectives like and, or, not, if then, and if and only if format. The quantifications, there are two types of quantification used in predicate logic. One is for all, to represent all the events or all the objects we can use for all notation, and to represent few things we can use the second notation called there exist. For example, this is a sentence, Spot is a cat. So here Spot is a subject, is a cat is a predicate. So how to write this in predicate logic is cat of Spot. And in well-formed formula, we could able to represent all the sentences with quantifications. And this is the Backus normal for first order logic. That means the grammatical representation of first order logic. So here everything is started with a sentence. So S is equivalent to sentence, and the sentence may be either atomic sentence or it could be a complex sentence. If it is a complex sentence, it could be connected by connectives. And if the sentence is represented by quantification, we have to use a variable. And in the beginning, we are representing the quantification. Either it could be for all or there exist. And also we can able to represent the negative sentences by representing a keyword not. And this is the atomic sentence. Atomic sentence is followed by a predicate. Within that, we have to write the terms or subject. And it could be either function or it could be a constant or variables. And these are the connectives and or implies an equivalent. And there are two types of quantification. There exist and for all. These are the examples of constants. These are the examples of variables. This is predicate, and these are the examples of functions. Let us see some of the examples or sentences, how we can convert the sentences to first order logic. Let us assume there are 9 sentences. So the first sentence is Marcus was a man. So here Marcus is a subject, was a man is a predicate. So in logic representation, first write predicate man. Within that, you can write the subject. You have to omit all the stop words like verbs and other prepositions and all. The next one is Marcus was a Pompeian. So here Pompeian is a predicate. So therefore Pompeian of Marcus. And third one is all Pompeians were Romans. Here there is a difference between this sentences differ with the previous sentences. Here we have a quantification called all. So to represent the quantification, we are introducing a variable x and the quantifier for all x. So if we are using for all x or any quantification, then that sentence could be represented in if then format. So therefore the subject is represented in if part and in the predicate is represented in then part. So if x is a Pompeian, then x is a Roman. And the fourth sentence is Caesar was a ruler. It's a very simple sentence. That is, yes, Caesar is a subject, was a ruler is a predicate. So therefore ruler of Caesar. And the fifth sentence, again we have a quantification. All Romans is a subject, were either loyal to Caesar or hated him. This is a predicate. And here you have consider in the predicate we have complex sentence. There are two predicates, loyal to Caesar and hated Caesar. So which these two sentences are connected by means of a connective called logical or. So that representation should be reflected in first order logic. So for all, we are introducing a variable for all. If X is a Roman, that is a subject. And in the predicate part, we are writing this one. X is loyal to Caesar or X is hate Caesar. So here there is a correction, X comma Caesar. And next one is everyone is loyal to someone. So in the previous case, we have all keyword. Here we have everyone. So everyone is used to represent all the person. So therefore you are using for all. And here someone is used to represent few things. So few people. So therefore we have to introduce the next quantifier. There exist. So here our objectives used to represent two variables, X as well as Y. So X is used to represent everyone. Y is representing someone. And the predicate is loyal to. So X is loyal to Y. So that is represented by loyal to X comma Y. Next, seventh one. People only try to assassinate rulers that are not loyal to. So here S is a people. And in the predicate part, we have complex sentence. First one is try to assassinate rulers they are not loyal to. So here we have people represent all the persons. Rulers means all the rulers. So we are introducing two quantifiers for all X. There exists Y. So for all people. If Y is a ruler and X will try assassinate Y if X is not loyal to Y. So here the predicate part is represented in if then format. If X is try assassinate Y, if X is not loyal to Y. Next, eighth one is Marcus tried to assassinate Caesar. So here the subject is Marcus. Tried to assassinate Caesar is a predicate. So there is no quantification, just try the predicate, try assassinate of Marcus comma Caesar. And next, the last one is all men are people. So here all is a quantifier. So you have to use for all X. If X is a man, then X is a person. Thank you.